Hello, here's a video for the material in Chapter 10, Section 6. The title of the section is Odds and Expectation. Um, so let's move ahead. We'll start with odds. The first thing is that odds is another way to write about the same information that's involved in probability. Casinos and stuff like to quote things with odds for some reason. I'm not sure why. I suspect it's because it makes it a little less obvious how likely you are to lose if you bet on this thing. So let's go ahead. First, as a reminder, remember E, if E is an event, the probability of E is the probability that the event E will occur. So P of E, right? And the way you calculate that, it's the number of ways that the event E can occur divided by the total number of possible outcomes in that situation. Okay? Now let's go into 10.6. Odds are another way of describing the probability that an event will happen. If event E has A favorable outcomes and B unfavorable outcomes, then the probability of E is A over A plus B, right? So this is what we've been doing. The probability of an event is A, remember, which is the number of favorable outcomes. In other words, that's the number of ways for E to happen over the total number, and they're just breaking that up into the number of ways that E can happen plus the number of ways it doesn't happen, right? So this is really the same thing, number of ways E can happen divided by the total number of things that could happen. Now, if you're going to do odds, you quote them two ways. Odds in favor, all right? Then what you do, since A is the number of ways before, right, you do A over B. So odds in favor, you either write it as the number of ways it can happen, colon the number of ways it doesn't happen, or you write it as a fraction ratio, right? And then odds against, it's the same two numbers, but you put the counting the number of ways it doesn't happen first, right? Okay. So when you see odds in favor or odds against in a question, you just have to count them up and put them in. All right, so for example, a card is drawn from a standard deck of 52 cards. A, find the odds in favor of getting an ace. All right. So there's 52 cards. There's 4 aces. So that means there's 48, and we'll call them non-aces, if you will, right? 48 cards that are not aces. So A is the odds in favor. So we put the number of ways of getting aces first and divide that by the number of ways of getting something other than an ace. All right. B is against. So we put the 48 on top because that's the number of ways to not get an ace, and then the 4 on the bottom, which is the number of ways to get. And then if we wanted to quote it as a probability, the number of ways to get an ace, there's 4 aces, right? Over both, the number of ways to get an ace, the number of ways to get something else is 4 over 52, and then that reduces to 1 over 13. Okay? Odds in favor, 4 ways to win compared to 48 ways to lose. Odds against, 48 ways to lose, 4 ways to win. What are the odds in favor of rolling a prime number with a roll of 2 dice? All right, so it doesn't specify, so we're going to assume 2 regular 6-sided dice. So there's 12 numbers, right? The 12 possible numbers are 1 to 12. Well, how many of those are prime? So a prime number is a number bigger than 1 that doesn't have any divisors other than 1 in itself, right? So the prime numbers between 1 and 12 are 2, 3, 5, 7, and 11. That's 1, 2, 3, 4. There are 5 of them. 5 primes. All right, odds in favor then. So there's 5 ways to win, right? That leaves 7 ways to lose. So the odds in favor, 5/7. The odds against, we just put the number of ways to not get a prime first, 7/5. All right, let's move on. Now the next topic that we're going to talk about here is expected value. So here's the formula for it. I know it looks kind of messy. When we talk about the expected value of x, so that's the expected value of an outcome in the situation. You take each, see x1 is one outcome, x2 is another outcome, right? x3 would be another, up to however many they have. And what it is you take each outcome like x1 and you multiply it times the probability of x1, plus the next outcome times the probability of that outcome, plus the next one times the probability of that one, until you've listed, until you've added up really every outcome times its probability. All right, so that's the expected value. Okay, and in a sense, so the symbol for the expected value of in a situation is capital E of x, and in another way, it's the average value. It's the average value in a situation where probability is involved. Okay. So let's do a few examples and see how this works out. These questions, it's worth the effort to try to be real organized about it when you do it. All right, so a single 4-sided die is rolled. So this is one of those kind of funky die. It's pyramid shaped on the sides, and on the bottom is a triangle. So no matter, it's got 4 triangular shaped sides that are identical. Okay, so single 4-sided die. So the number, so the possible the face, there's 4 numbers on it, right? 1, 2, 3, and 4. Find the expected value of the outcome and describe what that means. All right. So here's what I mean about being organized. So our possible outcomes here, our x's are 1, 2, 3, and 4. Then the probability of each x, we'll list those. In this case, since this is a fair die, and there's 4 of them, the probability on each one is 1/4, right? I mean, if you wanted to, you could write it as a decimal, whichever. All right, 1/4, 0.25, either one of those is fine. Now, then the next step, we're going to take each of the possible outcomes and multiply it times its probability. All right, so 1 times 1/4, we're going to add these all up, so I'm going to write them as decimals. 1 times 0.25 is 0.25, 2 times 0.25 is 0.5, 3 times 0.25 is 0.75, and 4 times 0.25 is 1, right? Then the expected value, you just add all those up, and that is going to add up to 2.5. Okay, so what is the expected value? There's a couple different ways to look at it. You could say it's the average value if you rolled it a bunch of times. It's what you'd. Another way to put this is it really says it's the average you'd expect if you did this a lot of times. All right. What would you expect the average result of this situation to be if you did this a lot of times? That's the expected value, and in this case, it's 2.5. Let's go on to another case. This one's more like one of the typical kind of questions you'll get in the homework. The prize in a raffle is a super high def plasma TV valued at $3,500. 5,000 tickets are sold at a cost of $1 per ticket. What's the expected value if you buy 1 ticket? All right. So first we'll list our outcomes. Okay. Now in this case, you either win or lose, right? You either win or you lose. Those are the only outcomes. So what happens if you win? Well, if you win, you get a $3,500 TV, but you also paid $1 for the ticket, right? So if you win, what happens is you essentially make $3,499, $3,500 minus the one for the ticket. Now you have to pay attention to these things because every once in a while you'll get one of these that says they'll also refund the ticket cost to you. So usually it's the value of the prize minus the cost of the ticket, but every once in a while they also kick in the cost of the ticket and give it back. So you got to watch that. In those cases, it'd actually just be the value of the prize. All right, what happens if you lose? Well, if you lose, what happened is you just lost your dollar, right? You paid $1 for the ticket. So the two possible outcomes for this thing are you win $3,499 or you lose $1. All right, we'll always do these in terms of dollars. Now we list the probabilities of each one. Well, there, it says, you'll notice it says there's 5,000 tickets here, right? And there's only one winning ticket. So the probability of winning is 1 out of 5,000. All right, so the other 4,999 tickets lose. That's the probability of losing. All right. Now we have to do our the outcome times the probability of the outcome. All right. So what we get here is when you multiply these together as a decimal, it turns out to be 0.6998. And then this one, notice, remember, so we have a negative here. Negative 1 times 4,999 over 5,000 is negative 0.9998. All right. So then my expected value for this whole situation, for this raffle, you add those two together, you're going to get negative 0.3. That's the expected value. Now, why is it negative? Well, it's negative because, I mean, it's a raffle, right? And the organization running the raffle is expected to make money, which means the people playing the raffle are expected to lose money, right? So the chances are, I mean, the long-term expectation if they sell all these raffle tickets is your average ticket value is like negative 0.3, which average is kind of a funny thing in this situation, right? It's negative $1 for all but one person, and it's plus $3,499 for that other person. Okay, so that is how expected value works. I hope you found this helpful. You'll see this in general is the way the homework questions work as well.